Okay, so we're given the RMS current here for this circuit, and we're asked to find the capacitance. I think we're going to have to start by finding the impedance. So we have the equation that the RMS current is equal to the RMS voltage divided by the impedance Z. And so Z is equal to that EMF divided by current, which is 120 divided by 0.87, or 138 ohms. Okay, now, in this case, there's no inductor, so the impedance is just the resistance plus the inductive capacitance, or the capacitor reactance. Inductive capacitance doesn't make any sense. Alright, and then this is 138 squared, and the resistance is given to be 55. And so when we solve for x sub c squared, it's 16,000. Therefore, x sub c is 126. That's equal to 1 over 2 pi fc. The frequency is given as 60 hertz. And so when I solve for the capacitance, I get 21 microfarads. Okay, so there's your part A. Part B, the maximum voltage drop across the resistor. Well, the maximum current is the square root of 2 times the RMS current, so that's 1.23 amps. And the maximum voltage drop across the resistor is just equal to the maximum current times the resistance. So that's 68 volts. Now part C, the maximum voltage drop across the capacitor, well, that's Imax times x sub c. Right, so that's 1.23, and then x sub c we have up here is 126, so that's 155 volts. Okay, and part D, it says, okay, so when the current is equal to 0, what's going on? So, well, when the current is equal to 0, that means the voltage drop across the resistor is equal to 0, because the voltage drop, the resistor, is in phase with the current. That is, when the current is 0, the voltage drop across the resistor is 0. When the current is maximized, the voltage drop across the resistor is maximized, and so forth. It happens at the same time. Now, at this time, delta V across the capacitor must equal its maximum possible value, right? Because why else would the current be 0? The current is blocked in this case. The current is 0, and so the voltage drop across the capacitor at that time must be 155 volts, right? And of course, the loop rule works at that moment. So at that moment, the voltage drop across the power source. So the voltage drop across the resistor is 0, the voltage drop across the capacitor is 155, and the voltage drop across the power source at that moment must equal the sum of these two things, right? That's the loop rule. Now remember, the loop rule doesn't work for averages, right? You can't take, and it doesn't work for maximum, because, right, this voltage here and this voltage here occur at different times. So you can't just always add up, maximum, but at any given instant, like at t equals 0 or when I equals 0, you can use the loop rule. And so that means the voltage drop across the battery is 155 volts at that time.